Welcome to lesson 18 in our series about learning Python for beginners. In this lesson, we'll see some exercises that will make practical use of what we've learned about loops. In this lesson, we'll briefly recap what you've learned about counting the number of iterations of a loop and totaling a series of values through a loop. We'll look at some other calculations that we can do with loops. We'll look at how we can nest loops inside other loops, and we'll look at the command to break a loop. So let's quickly recap. Here's a program that counts the number of iterations of a loop. Numbers are entered one after the other. The loop will stop when 0 is entered, and a counter variable called count in this instance increments every time the loop repeats. We've also learned how to add up a total. This program will also repeat until the user enters the number 0. A total is set to 0, and that number is added to the total every time round the loop, and the total is output at the end. And now we're going to look at some other ways that we can use loops in programs to calculate the average of a series of values, to find the largest number in a series of values, and to find the smallest number in a series of values entered by the user. To calculate an average, we'd set count and total to 0 before the loop begins. Every time that the loop repeats, we add 1 to the counter and we input a value and add that to the total. So those two commands occur inside the loop. At the end of the program, after the loop is completed, we would divide the total by the count to give the average and output that result. So let's look at an example of a Python program to calculate an average. You'll see it has all the features that we've just looked at. Before the loop begins, a counter and a total are both set to 0. The loop is a condition-controlled loop, so it has a logical test. The variable used in the logical test is called more, and we set the value of that variable before the loop begins. Inside the loop, we enter a number, we add that number to the total, and we increment the counter by 1. And finally, we give the user an opportunity to say whether they want the loop to repeat again or not. When the loop's finished, we calculate the average by dividing the total by the counter, and then we output the average. You can have a go at entering that program just as is, and if you like an extra challenge, adapt this program so that it uses a counter-controlled loop instead of a condition-controlled loop. In that instance, you won't have to increment the counter variable because that will happen automatically. If we want to find the largest in a series of numbers, we use a somewhat similar structure. Before the loop begins, we set a variable called largest to 0. Inside the loop, we input values one by one, and each time round the loop, we'll compare the value that has just been input to the largest. If it is larger, this value becomes the new largest value. We'll continue that until the end, and then when the loop's finished, we'll output the largest number. So here's an example of a program to calculate the largest in a series of numbers. In this example, I've used a counter-controlled loop. The value of largest is set to 0 before the loop begins. Every time round the loop, the user enters a number, and then there is an if structure embedded or nested inside the loop. Every time round the loop, the number input by the user is compared with the largest value, and if the number entered is larger than the current largest value, then the largest value is replaced by the current number. At the end of the loop, we print out the value that has been the largest. So have a go at entering that and try it out for yourself to make sure that it works. You can then adapt the program so that it uses a condition-controlled loop, a while loop, instead of a for loop, and that will give you some extra practice in using different types of loops. To calculate the smallest, we do a very similar thing. We'd start by setting the smallest to a very large number, larger than any of the numbers that we're going to enter during our, as we enter numbers one at a time. Inside the loop, we'll input the new values and we'll compare each one to the smallest. If it is smaller, it will become the new smallest value and we'll output the result at the end of the loop. I'm not going to show you how to do that. It's an adaptation of the program that you've just looked at to calculate the largest. So have a go at doing that on your own without any help. Here are some extra exercises for you to try. There are 5 in all, so after I've gone through them, pause the video and have a go at as many of these as you can manage. Create a program where you can input the temperature for 7 days. Don't really wait a day in between entering those numbers, just input 7 temperatures and it will output the average temperature. Create a program where a teacher can input 5 exam marks and it will output the highest mark achieved. Change that program using a number of different methods that we've learned so that the teacher can decide how many exam marks she wants to enter. Expand that program so that every time round the loop the teacher enters the name of the student as well as the mark, and it will record and output the name of the student who had the highest mark in the exam. And finally, create a larger program where the user enters a series of numbers and the program will work out the mean, the median and the mode of those numbers. If you're not sure what that means, look in a maths textbook. So those are some extra challenges for you. But this lesson isn't finished yet. There are some other skills about loops for you to learn about. The first thing I want to look at is a nested loop. That's a loop inside a loop. This example isn't a nested loop, it's just a simple loop. For I, the counter variable, in the range 0 up to 12, it will print out the 0 times table, the 1 times table, and so on. The \n, do you remember what that means? It's an empty line, so it'll throw an empty line. And then after it's printed out that phrase, it will just ask the user to press any key. And because that's an input line, the computer will hang until the user presses a key. Now we've put a loop inside a loop so that as well as just saying the 1 times table, the 2 times table, it will actually print out all the numbers in that times table. So we've got a for loop using the counter I, and inside it another for loop using the counter J. That's a bit of a convention in programming circles. If we have a loop inside, a counter inside another counter loop, we use I for the first counter and J for the second one. If we use the same counter in both loops, then the program will go wrong. So you can simply try copying that program for now to see what happens, and you could try variations on it. Sometimes you need to break out of a loop at some point that is not the top of the loop where the while test is. So let's look at an example of that. Your condition controlled loop could start with a command such as while true. That's a loop that will never stop. For instance, we could enter numbers and the loop will literally never stop asking us to enter numbers. If we've got a loop like that and we want to stop the loop further down in one of the commands inside the loop, we can use a command called break. That's a Python keyword. And in this example, if the user enters the number 0, then break, and that will stop the loop. I would try to avoid this kind of method for stopping a loop. It's much more sensible to use a condition inside the while command. But sometimes it is necessary, and we'll look at some examples later on where this is the most elegant way to work with the loop. So to recap, we've looked at how to calculate averages using counter loops and conditional loops. We've also looked at how to create how to find the largest and smallest value in a series of numbers using a loop. We've briefly looked at nested loops, that's loops inside of other loops, and we've looked at how we can use the break command to stop a loop, though that is usually not the best method to learn. Okay, so that concludes what we've been learning about loops. Here is a final exercise that will let you apply your knowledge about loops, and it's to create a car park regulation system. Let's imagine a car park has 20 spaces. You can change that to a different number if you want. Create a program to keep track of the number of spaces that are free inside a car park. Typically, the barrier of a car park will have a program like this in it. Enter plus to represent a car entering the car park, and enter minus to represent a car leaving the car park. And this would be enclosed in a loop which will repeat and output the number of spaces that are left in the car park. When the car park is full, you can't add any more cars to the car park, but you can take away. A warning message will be displayed, and if you enter anything except the plus or minus, the loop will stop. So this will apply a lot of the different skills that you've learned. So see if you can get that working, and if you can, that shows you've really learned everything that we've done about counter and condition controlled loops. So bye for now.